हेलो गाइस, वेलकम बैक टू ऋतुराज एंड वायर्स। आज है डे 24 ऑफ 25 डेज आईओटी सीरीज और आज हम करने जा रहे हैं पावर मैनेजमेंट इन आईओटी। सो लेट्स बिगिन विद द डे 24 टॉपिक। तो या अब हम लोग के ये लास्ट दो लेक्चर बचे हैं इस सीरीज़ के एंड अब कल एक लास्ट लेक्चर होगा, फिर दिस सीरीज विल बी completed for only the theory and interview and exam parts. For the people who wants to know about practical things in IoT and how to make a project, or how, if you want to make a project on the things I have taught you, so you can follow up me for the project videos also that will come including this series only. So that will be a part of this series also, but it would be not like day 26 or day 27, but it would be longer of if I can say. So it is better that if you make a project with me, that because it might increase your knowledge. If you have watched this series in a flow, then yeah, if you make a project, that would be a practical level skill that you can show to your interviewer, or basically you can develop a skill and work on your interest. Okay, so let's begin with the content here without wasting any time. So our first topic today is introduction to power management in IoT, importance of power efficiency in IoT devices, power consumption sources in IoT, power modes in IoT devices, sleep mode, active, ideal, deep sleep. We are going to study all these types of sleep modes that save power, duty cycling concept, battery types used in IoT, energy harvesting techniques, sorry for the misprint, power optimization techniques, and power management challenges in IoT. So let's begin up with our first topic. So our first topic today is introduction to power management in IoT. So power management in IoT refers to the controlling, reducing, and optimizing power consumption of an IoT device so they can operate for long period without frequent battery replacement or charging. Most IoT devices are battery powered, deployed in remote areas, expected to run for months or years, hence power management is critical. See, basically I would just make you understand this whole paragraph with one simple example that is gonna struck your mind. Okay, so what is that example? I'm gonna also use that example when I give you the questions and when I will teach you the solution or show you the solution. Okay, so basically imagine a situation when you are an IoT engineer and you got a contract, your company got a contract that you have to, we can say, you have to deploy a climate sensor, or we can say a fire sensor in California forest. That is one of the dreaded forest for their fire tragedies that happens all over the years. So if you deploy we can say in summer times, you deploy a sensor there. Okay, so you cannot and a battery that can last up to only a day. Okay, so what will happen as an IoT engineer, you only know, you are the we can say that you are a single-handedly a part of the team, and you have been assigned the task of power management, and you got the choice to make we can say that to fit a 1 day battery or a year battery. So in the first case, you fit a year battery, we can say a day battery. Okay, so what would happen after a day, the battery will get discharged and you have to then go back, charge the battery, or we can say replace the battery. Okay, so that is not physically possible. If you are going every day we can say in a forest and coming back, that is dangerous. And why it is dangerous, you all know that they are wild animals, and that is a hell lot of trekking we can say that you have to do just to go out to the deployment ranges, find the deployment devices. Okay, so what do we do in this situation? We apply a battery that would last at most a year. Okay, that is our second case, when we apply a battery or we assign a battery to the device that can last up to a year. So that would be a possible case scenario where we go once a year to just change the battery, we can say in all the different types of devices that has been deployed all over the forest. Okay, so yeah, I guess so you all got what is the power management in IoT and why it is required. Okay, so yeah, basically let's move on to the second topic. So our second topic today is importance of power efficiency in IoT devices. So efficient power usage helps to increase device lifetime, reduce maintenance cost, improve reliability, enable large scale deployment. Poor power management leads to frequent battery replacement, device failure, and increased operational cost. So with the example that I just made you understand, you might get what is the what happens when you have a poor power management. Okay, so it would need you to frequently replace the batteries. The device failure would happen frequently, increase operational cost because you have to do tracking, and also the manpower would be way much required for this. So how do we reduce this? We can say that how can we do a good power management in here, or efficient power usage. So increase device lifetime, that means we have to make we can say that the battery that we are going to apply in the IoT devices can last up to a year, and reduce maintenance cost and improve reliability. Okay, so that is basically the functional security of our devices, and how good the quality and the build quality of our device is. Okay, let's move on to the third topic. Our third topic is power consumption sources in IoT. So, major source of power consumption include sensor, data sensing, microcontroller processing, communication modules, Wi-Fi, GSM, and LoRaWAN or LoRa, actuator, motor, relay, and display. Among this, wireless communication consumes the most power. Okay, so if I say that if you are a beginner in IoT and you are just watching this video from basically this is the first time you're learning about IoT, so it might struck you that this would be the least interested thing that you would say that this communication thing would just, we can say that it would take the least amount of power from our IoT device. Anyone would think that, but the result is just quite opposite. Reality is just quite opposite. Is that wireless communication consumes the most power. Okay, then sensors come, then microcontroller, and then communication module. The communication module is basically communication, and then actuator, motor, relay, and display. So I think the second part is the actuator that consumes the most power here, and then the sensor, and then the microcontroller because it processes the data. Okay, so hope you all get that. Let's move on to the fourth topic. Our fourth topic today is power modes in IoT devices. So IoT devices operate in different power modes to save energy. Active mode, device is fully working. Idle mode, CPU running but no task. Okay, so sleep mode, most component turned off, switching between modes, reducing unnecessary power usage. So we have just talked about three types of mode. One is active mode, in which device is fully functional, it is working its tasks, it is being used. Ideal mode, when the only the CPU running but no task is actually being taken, or we can say no action is taken. And sleep mode, when we can say our device is taking a rest, or we can say the main system or the core system of the device is just shut off, but the power is being used. Okay, in some type of we can say sleep mode. You all know that, you all have that in your computer and laptops and your mobile phones, so you basically know what is a sleep mode. It just makes your device power efficient and saves its battery. Okay, by just switching off all the different component that use power for useless things. Okay, if you do not require them. Let's move on to the fifth topic, sleep modes in IoT. So sleep modes are the most effective power saving method. Common sleep modes are light sleep, when CPU is just paused, memory is retained. Deep sleep, CPU is completely off, minimal power usage. And hibernate, almost completely shut down, means the whole IoT system is almost completely shut down, not just only the CPUs. And deep sleep is widely used in ESP32 and ESP8266, when CPU is just off and all the different types of components in the IoT devices, some are on and some are off, depending on the requirements of their usage. Okay, let's move on to the sixth topic. Our sixth topic is duty cycling concepts. So duty cycling means device stays active only when required and sleeps the rest of the time. Example, wake up every 10 minutes, read sensor data, send data, go back to sleep. This dramatically increase battery lives. Okay, so duty cycling means device stays active only when required and sleep the rest of the time. Example, wake up every 10 minutes. So basically we can say that we can use this method in the forest example. Like there can be a gap of for sensing the temperature, or we can say if there is a fire in the forest. 10 minutes cannot make a huge difference. Only when the fire gets too large, then it might make a difference. But if we have deployed efficiently all over the forest, then 10 minutes every device can get a sleep where it saves its power, and another 10 minutes it can work just sensing the environment. So that way we can just effectively manage our power. Okay, save some power for IoT devices and make it run longer. So that's the thing we are discussing here. So let's move on to the seventh topic, Battery types used in IoT. So common battery type that are used in IoT are lithium ion battery, lithium polymer ion battery, coin cell batteries. Coin cell is the basic that we beginners use for our small level IoT projects. Alkaline batteries, selection depends on voltage requirement and capacity and cost and environment. Okay, what environment you are using and what is your budget for your IoT system. It actually depends on the level of project you are making. If you are making a beginner friendly project, so it basically requires around in India $15 to $30 and outside India I don't know much about the cost, but it might cost you a little bit more. In India, if you are making an intermediate level project, it would cost you around 6 to 7 thousand if it have automation and different types of things that are being present in the today's world. So yeah, that is pretty basically all. So let's move on to the eighth topic. Our eighth topic today is energy harvesting techniques. So energy harvesting means generating power from surrounding sources. Common techniques are solar energy, thermal energy, vibration energy, and radio frequency energy, that we call the as RF energy, used when battery replacement is difficult. So this is a good form of power management that we can use. We all know about the different types of solar devices that we use today in India. Also, we have a good system of solar panels in our home, in our terrace, so we can use some sunlight to change it to electrical power. And yeah, pretty much basic, we can save a huge amount of money, and we can also say that a huge amount of electricity too. Okay, we can also sell that extra electricity for money. So that is the same thing that we use in IoT, but in a different concept way. It's like solar energy helps us to reduce the main power, or we can say there is always a battery that is getting charged. Okay, we can say that there is a battery that can last up to 1 year, but somehow there is a condition in the forest that we cannot reach the IoT device, but we need that IoT device to work. So we can deploy an extra cell that we can use, that can use itself with a solar energy power. Okay, so that was a good example to make you understand energy harvesting techniques. Okay, let's move on to the ninth topic. So our ninth topic is power optimization techniques. So ways to reduce power consumption: use low power sensors, reduce data transmission frequency, and optimize code. Use sleep modes, choose low power communication and protocols. So these are different types of method you can use for power management and power optimization. So our first was way to reduce power consumption: use low power sensors. Means if you are using a low power sensor, your quality might be affected, but still we are developing a pretty much basic good types of sensor that can use way less power and can work effectively as a good level sensor, a quality level sensor. And the second is reduce data transmission frequency. Means that the packets, if you're following this series from the start, I have taught you about the packets, how the data that is being collected in the sensor can be stored in a packet, and once a packet stores a level of data, then the packets goes to the cloud. Okay, so you don't have to continuously send the data every minute, or we can say continuously send the data that consumes a lot of power. Okay, I have discussed this in a very brief concept when I was discussing in day 1918, if I guess so. Yeah, you might know that. Okay, so optimize code, use sleep modes, and choose low power communication protocol. Okay, hope you all get that. Let's move on to the 10th topic. So our 10th topic is power management challenges in IoT. So major challenges include limited battery capacity, harsh environmental conditions, continuous connectivity requirements, balancing performance versus power. Designers must trade functionality for efficiency. Okay, so sometimes we don't see, the more simpler your system is, the less power it will consume. The more complex your system is, the more power it's consumed. It's pretty much basically that. Okay, hope you all get that. This whole paragraph mean that. Okay, the designer must trade functionality for the efficiency. Means that functionality is inversely proportional to efficiency. The functionality increases, the efficiency decreases. Okay, so yeah, that is pretty much and it sums it all. Okay, let's move on to the Oh, we have an interview part also here. So this is some interview point that you have. We can say that this is a summary point that what we have learned today is framed here. So communication use maximum power. Sleep modes are key to long battery life. Duty cycling is widely used. That is a power saving mechanism. Energy harvesting reduces battery dependency. Power management is critical for scalability. Okay. Now, this is the most important part of the video. I want everyone to have a pen and copy with them. And please stop the video right here and just solve these questions. Write this in your copy. And when you have done it, restart the video from this part only, and then cross check the solutions with me. Okay. So, yeah, if you have completed the solution part and you are starting this video from right now, so let's discuss the answers. So we will first start with the short answers and then MCQs, because MCQs are pretty much basically a part of the short answer only. If you get the short answer, you can answer the MCQs. Okay, so our first question in the MCQs is define power management in IoT. So first I will read the concept and then I will make you understand that also. So power management refers to the hardware. Sorry for that hiccups. Let me be calm. Yeah, let's move on. Power management refers to the hardware and software techniques used to minimize the energy consumption of an IoT device while ensuring it still performs its required tasks. Think of it like a smartphone battery saver mode. It manages resources to make sure the device doesn't die quickly. Pretty much basically it we can say that how our mobile devices work. When we have a low level of battery and we don't have a charger with us right now and we cannot charge our phone, what do? We just click on our battery saver button, and the battery saver button just we can say that it blocks the extra power that the background apps consume. Okay, they just cut them off, the extra useless power that they consume. Okay, and only makes sure that only the apps that are being required for us, like we can say chatting app, these types of app that are being used in emergency or pretty much basic use, that are being opened only. And yeah, that is how IoT system also saves its energy. They use this same technique, but for devices and sensors. They use deep sleeps for power management. We already discussed that. So let's move on to the second question. Why is power efficiency important? So many IoT devices run on batteries and are placed in remote location where changing batteries is difficult or expensive. Efficiency is crucial to extend the device lifespan. Okay, so if a sensor is in a forest detecting fire, the example that I made you understand in the first part of the video, you can't go change the battery every week. It's need to efficient enough to last a year. Okay, as I was discussing with you that this was a good example to make you understand why power efficiency is important in IoT system. So yeah, we need power efficiency if we are deploying our system. Most of the IoT devices are deployed in a high place, a high altitude place, for we can say that for measuring the winds that are being up there, or we can say the climate places, or in remote areas, in agriculture also. So yeah, we do not want to get every week to our system and do the updates or replace the battery manually. So that is a very hell of a task. So what do? We do things with OTA. We just discussed it in the previous video, day 23, and over the air updates. Please watch that video if you haven't, because that is an important topic for IoT. And yeah, you need that. And the power efficiency part, you already get that. So let's move on to the third question. Sorry for the misprint. That is what, not had. So what is deep sleep mode? Okay, so we know pretty much about deep sleep mode. What is it? How does it happen? And it is one of the most important feature that ESP8266 and ESP32 use in their microcontroller for saving energy. Okay, so this is an ultra low power state where the microcontroller shuts down almost all internal components, CPU, Wi-Fi, sensor, leaving only a basic timer or wake up pin active. Okay, and it is like a bear hibernating. This device is asleep and doing nothing until a specific time or event wakes it up to work. Okay, so it would pretty much basically work only when we can say that we deployed a sensor that would only work in summer season. Like we deployed a sensor in California forest when only the summer comes up. Okay, because the forest fire in California starts only when the summer gets heated up, and yeah, so we apply a sensor that only works in the summer season, and for the rest of the season it gets off, saving its energy. So if we apply a battery that can last up to a year, so if it only gets on during the summer season, it can last up to 3 to 4 summer seasons. Means we can use that same battery that can be used for only a year. We can say that measuring the temperature or fire alarm in winter, that is not required, can last up to 4 year. Okay, hope you all get that. Okay, so let's move on to the fourth question. What is duty cycling? So duty cycling is the practice of periodically switching a device between active and sleep state. Instead of being on 100% off all the time, the device might be on for 1% and off for 99%. So duty cycling majorly means that the device only gets on when it is required to need to get on. Okay, when it is need to get some work done, it only gets on when only it needs to get work done, and 99% of the time it is in deep sleep mode, saving its energy. Okay, so deep sleep mode can be a part of duty cycling. Okay, duty cycling is a feature that is being employed in IoT devices for, we can say, power efficiency. Yeah, let's move on to the fifth question. Name one power management challenge. So, balancing performance versus battery life. The challenge is figuring out how to send data frequently enough to be useful without draining the battery too fast. If you want live videos update, the batteries dies fast. If you want 5 year battery life, you can only send a text once a day, finding the middle ground in the challenge. So this is a good example that we can make a live video that will drain your phone battery in just about an hour, and we can just send text and shut down our phone, then just send text every day, simple text message to our friend, and it can last up to a 5 year. That is not reasonably possible, but still that is a good example to make you understand how can one power management can face a challenge. Okay, so balancing performance versus battery life. The challenge is figuring out how to send data frequently enough to be useful without draining the battery too fast. So we are using the same concept in IoT, that we would only send the data when it is, we can say, we have set a warning limit that the temperature should not rise up to 20 more than 25 degrees Celsius. If it is rising more than 25 degrees Celsius, the sensor would send a, we can say, a warning or alert to our dashboard or system via cloud. Okay. Yeah. So yeah, we have the MCQs left. So the first question is, owner management mainly needs to increase battery life. Okay, so our answer would be B, option B, increase battery life. So the primary goal is to stop the battery from draining quickly. So the owner management mainly, sorry, I'm dictating the power management as owner management because of the misprint. I'm so sorry for that. Please don't mind. Yeah, the power management mainly helps to increase the battery life. The option B is the correct answer. Second question is, which mode consumes least power? So the primary goal is to stop the battery from draining quickly. That was the first answer. So deep sleep mode is the correct answer, because deep sleep mode is something I've already explained you that. I don't need to explain you that again here. So you get why deep sleep mode is the best. Duty cycling is a method, not a feature. Deep sleep mode is a feature. So which component consumes most power? So we already know that communication modules consume most of the power, because it has to send data, we can say, over a period of time. Doesn't matter if you send data through packets too, it still needs energy, and it needs a lot of energy. Okay, it consumes a lot of power of the IoT system. Okay, that's why we use packets and not continuous data transfer. That is not required. We can say that we use sometime, we need data, continuous data system, we can say data communication, when we are doing something particularly very risky thing, like I used this example before in a video, that like we are working in a gas industry. Okay, gas making industry, and a gas leakage happens. Okay, if the data is being stored in a packet and send it to the, we can say, the cloud after 10 to 15 minutes after gas leakage, the harm would be done, many people would be injured. So that is where we need a continuous data system. Okay, communication system. Hope you all get that. If you have any doubt, you can still ask me. I am always active and looking out for the questions that I can solve and answer. So the fourth question is duty cycling means continuous operation, random sleep, scheduled sleep and wake, device shutdown. So you all know that the answer would be option C, scheduled sleep and wake. Okay, so it is a planned cycle of working and resting. Okay. Fifth question is which is an energy harvesting source? Okay, so an energy harvesting source is solar. So batteries and adapter provide stored or grid power. Harvesting means gathering free energy from the environment, like this, like the sun, solar, wind, or vibration. So as I made you understand before also that we cannot just only depend on solar energy. That is not a good thing, but when we pair it up with a stored energy and a solar energy, that could give the battery or charge the battery on its own sometime, can just increase our whole battery efficiency and power management, while also we can say making our device reliable on both the side. Okay, sometime our battery just get dead and we do not have extra battery to or extra person to get there and repair it. So the solar system can just give us the power to run the IoT system for days or hour or some. Okay, yeah, so that was all for today for the day 24. Hope you all get that. If you have any doubt, as I said, please comment me out. I'm always seeking out for questions and I would like to solve your queries. If you yeah, please comment out. I want to answer your questions. And yeah, that was all. We would meet in day 25 tomorrow. So okay, bye.
And now, folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.